Hello, so this is supposed to be a Math Monday video. It's Wednesday right now, but that's okay. So I wanted to make a sequel to the Parabola reflection video that I made, but going more in depth, right? Because in that video we had y is equal to x squared, right? So we proved that paraboloid or parabolic mirrors will have a focus point. If y is equal to x squared, right? So if y is equal to x squared, but now we can ask, what about y is equal to any sort of quadratic equation, right? So if y is equal to ax squared plus bx plus c, right? Would it still have a focus point? And the answer would actually be yes. Yes, it would. And that's because if we look at a parabola, in the previous video, we set the line of symmetry to be equal to 0, right? So we set the line of symmetry to be equal to 0, but in this case, all we would have to change is to set the line of symmetry equal to negative b divided by 2a, right? And you can figure that out using algebra, or you can also take the derivative as well, right? So just set y prime equal to 0, and that's going to be equal to, if we just take the derivative, I'll kind of skip a couple steps, but we would just basically get subtract the b divided by 2a, sorry, and then you'd get negative b divided by 2a, right? That's going to be equal to x, right? So there's a couple ways to show that, but we know the line of symmetry is going to be negative b divided by 2a, right? And so that's where we would set it as, but then otherwise it would be exactly the same, right? We would get exactly the same equation, right? We would get exactly the same focus point. And it would be same if we change c, right? If we change c as well, c would just move the parabola up, right? It would move it up, or it would move it down, right? So it would just move it, and that wouldn't change anything, right? That wouldn't change the focus point of the parabola at all. And actually, it would also be the same with the y is equal to ax squared part. And and that would be because all you're doing when you change this value, right, the coefficient in front of x squared, you're just making it narrow, right? You're making the parabola narrow, or you're making the parabola very wide. But you would essentially have exactly the same focus point. Now the focus point would change, right? The focus point would get would be up higher for narrower parabolas, right? So it would be like up here. Then the focus point would be much smaller for the larger parabola. So it'd be like down there. Let me draw a better picture. So the focus point for like a wide parabola would be like down here. And the focus point for a narrow parabola would be like right there. And that's kind of also that makes sense to see, right? And that's because you can kind of think of these parabolas as like kind of like a zoomed in section, right? So you can think of like the wide parabola, so this red parabola, as a zoomed in section of this black parabola, right? So like it's like this smaller part. Now that's not exactly true, right? That's not exactly true, but intuitively it makes sense, since that would mean that Whether you make the parabola wider or narrower, all the points will converge to like this one focus point. And so I just made like a little program kind of to show how the rays of light will bounce off a parabola. So this might take a bit of time to animate. Something like that. And if we go just step by step, right around that point, right around the point where it crosses the center, right? So about there, that's where the focus point is going to be for this parabola. And I just I made it so we can change the variables, right? So this is ax squared, this is bx, and this is c. I'll attach the Jupyter Pi notebook in the description below. And basically, this animation will show you kind of like how the light rays will change depending on how the parabola, right? How wide, how narrow the parabola is. But it'll still show you that all of them will come to the same focus point. There's one last thing we have to talk about, and that is this angle, right? So we actually assumed that the light rays, right? That the light rays. Let me draw that in yellow. Actually, the light rays are all vertical, right? They're completely vertical. What if we had light rays that were at an angle, right? So we had light rays at an angle. So there's some certain theta, right? There's some certain theta that the light rays are hitting the parabola at. Well, then it actually turns out that that would break the line of symmetry, right? That would break the line of symmetry for the parabola. If you have a vertical line, there's a perfect line of symmetry, right? So because we have a line of symmetry, right, there's going to be this focus point on that line of symmetry. But if we actually have an angled light ray, right, if we have light rays coming at an angle, there is no line of symmetry, right, for the parabola. There's no way to really cut the parabola in a symmetrical way. So there's no way for the parabola to like focus, right? There's no way for the parabola to focus all the light onto one point, right? So if you have an angled light, you won't actually have focused light, a point where all the light focuses on. And that's about it. So kind of like a real world application for this is if you've ever wanted to make like a solar cooker, you can try making it in a parabolic shape, right? So you can make it in a, let me see if I can draw that better, but you can try making a parabolic mirror, so that all the light gets focused onto one point, right? So you have like this point here. Maybe you can put like a grill or something, right? So you can put like a grill here. And if you place it outside, the food will actually get very hot, depending on how big the parabolic mirror is. You can usually use like some people like to use satellite dishes, used satellite dishes, or you could probably make it out of wood, although that would be quite hard to do. Or if you wanted to, since parabolas are kind of hard to make without special materials, you can also just kind of approximate a parabola. So instead of making a parabola, perhaps you could make like a hexagon, right? Some sort of hexagon. In that way, although it's not a parabola, it'll still reflect most of the sunlight onto one spot, right? So it'll still focus most of the sunlight on one spot. It could be a hexagon, it could be some other like shape, but you can make all sorts of contraptions. So that's my challenge to you. Try to make something. Try to make a solar cooker using whatever materials you find in your house. You can use an aluminum foil, and you can use wooden frames. You can use maybe other pieces of furniture, for example. Try to get really creative. And I'd love to see the ideas you come up with. So that's the sequel to the Parabola video.